Every measurement has some uncertainty, in which it is called experimental error. Another definition of it is the difference between a measurement and a true value or between two measured values. So what are the types of experimental errors? Experimental errors is classified either systematic or random. Random error. Random error are also called as indeterminate error. It arises from uncontrolled and maybe uncontrollable variables in the measurement. Random error has an equal chance of being positive or negative. R has an equal chance of being positive or negative. It is always present and cannot be corrected. Systematic error, or also called as determinate error. It arises from a flaw in equipment or the design of an experiment. Systematic error is a consistent error that can be detected and corrected.
Ways to detect errors. First, analyze a known sample such as a certified reference material. Your method should reproduce the known answer. Number 2, analyze blank samples containing no analyte being sought. If you observe non-zero result, your method responds to more than you intend. Section 521 discusses different kinds of blanks. Number 3, use different analytical methods to measure the same quantity. If results do not agree, there is error in one or more of the methods. Number 4, round-robin experiment. Different people in several laboratories analyze identical samples by the same or different methods. Disagreement beyond the estimated random error is systematic error. Ways to minimize systematic errors. Number 1, collect representative samples. Number 2, analyze standard reference material whose concentrations are known. Number 3, analyze blank samples. Number 4, use sample methods to make measurements. Number 5, participate in a round-robin study with other labs. And number 6, vary the sample size. Calibration of apparatus. By calibrating all the measurements, errors can be minimized and appropriate corrections are applied to the original measurements. Control determination. Standard substance is used in experiment in identical experimental condition to minimize the errors. Accuracy. Accuracy describes how close a measured value is to the true value. If a known standard is available, accuracy is how close you value is the known value.
So here are examples of a random error. When applying it to real life situation, when you weigh yourself on a scale, you position yourself slightly differently each time, so you get different values. The next one is when you take a volume reading in a flask, you may read the value from a different angle each time. And measuring the mass of a sample on an analytical balance may produce different values as air circulates, affect the balance, or as water enters and leaves the specimen. And measuring your height is affected by minor posture changes. Also, these are some examples on systematic errors. Okay, number 1 is forgetting to tare or zero a balance produces mass measurements that are always off by the same amount. An error caused by not setting an instrument to zero prior to its use is called an offset error. Number 2, not reading the meniscus at eye level for a volume measurement will always result in an accurate reading. Number 3, measuring length with a metal ruler will give a different results at the cold temperatures than at the hot temperatures due to thermal expansion of the material. And number 4, an improperly calibrated thermometer may give accurate readings within a certain temperature range but become inaccurate at higher or lower temperatures.